In our class today, we're going to be studying graphing functions, but we are going to be stretching and shifting in the same situation. Whenever we're combining transformations, it's important to realize what number represents what thing, whether you have a shift or a stretch, horizontally or vertically. So let's go through. A number multiplied out front represents a vertical stretch. Remember, you multiply that number by the y's. A number being multiplied on the inside of the function represents a horizontal stretch. That number gets multiplied by the x's. And remember, it's the reciprocal that gets multiplied by the x's. The last two numbers represent the shifts. Inside of the function is a horizontal shift. Or left and right. Remember, you always go opposite of the sign. And a number being added or subtracted on the outside is a vertical shift. And you always go with the sign. Let's try an example. Before we go to our example, we want to focus on our steps for graphing. First and foremost, we always need to figure out what our parent function is and where our important points are. The second thing we need to consider is our stretches or compressions, depending on the number that's being multiplied. We need to take care of those before we can ever shift the graph. Shifting will be the final thing that you do. Always make sure that you label your final graph so that I know which one is your final answer. Here's our first example. G of x equals 3 times the square root of x minus 1. So here I know I have a vertical stretch. I'm going to multiply the y's by 3. Here I know I have a horizontal shift because it's on the inside of the function. So I'm going to go the opposite of the sign. So instead of going -1, I'm going to shift forward +1 or to the right 1. So let's look at my parent function. 0, 0, 1, 1, and 4, 2. Those are my 3 important points. Again, I always like to write down my important points. Whenever I'm dealing with stretching, because it helps me to figure out the appropriate stretch. So since the 3 is out front, every single y is going to get multiplied by 3. So 0, 0 stays 0, 0. 1, 1 becomes 1, 3. And 4, 2 becomes 4, 6. And I'll plot those new points on my graph. 0, 0, 1, 3, and 4, 6. So there's my stretch graph. And finally my shift. I'm going to the right one, so that means that I'm shifting every point in my stretch graph, in my green graph, over 1. So my final graph would be my purple graph. So it's important. Parent function first, then stretch, then shift. Let's try another example. We'll do this one. It is very, very, very important that first we pay attention to our parent function. Since this is a squared, I know that I have a parabola. In order to figure out my stretches, this inside portion of my function always has to be factored. So I have to do a little bit of extra thinking that I didn't have to do on the previous problem. So I'm going to factor a 3 out of here. Now I know my appropriate shift. If this isn't factored, then I would have shifted this to the right 12, which would have been very incorrect. So you might want to make a note to yourself. That this inside of the function always needs to be factored. Now, to my stretches and shifts. I have this negative number out front. That affects the y's, so each y gets multiplied by negative 1. This is interesting. Each x is going to get multiplied by the reciprocal of that, so 1/3. And then it looks like I'm going to shift opposite of the sign here to the right 4. And then I'm also going to shift up 2. So I have a lot of things happening in this graph. I always want to do my stretches first. And again, I like to list my points out so I know how to manipulate them. So every x gets multiplied by 1/3, and every y gets multiplied by negative 1. So this becomes negative 1/3, negative 1. This stays 0, 0 for now, and this becomes 1/3 multiplied by the x, and negative 1 multiplied by the y. So I've got 0, 0. I have to approximate where 1/3 is going to be. I'm just going to say it's about right there on both ends. So the graph is going to get wider and flip upside down. Now I can do my shift to the right 4 and up 2. I'll start with my center because that'll help. To the right 4, 1, 2, 3, 4, and up 2. To the right 4, 1, 2, 3, 4, and up 2. And to the right 4, and up 2. And so my final graph is here in yellow. Again, even though this process was complicated, I followed the same 3 steps. Figured out my parent function, figured out my stretches, then I figured out my shifts. If you have questions, please feel free to write them down and we will go over this more in class.